Okay, so here's a pretty good one. I like what he's doing, and obviously I want to change this out a little bit for 5 steps. Well, first, to a certain degree, we had to get run speed in the PT test, right? You know your run speed, and we can be a bit abusive with this equation that way while setting out the foundation to it. He's going to walk through what he's doing with it very well. uh, Hopefully that's the kind of context that you would do the result for, and to a certain degree that's what I'm going to do. I'm just not for totally sure if I want these numbers. See, I want the base equation to it to say each part of the problem first determines the range of run speeds. And because, well, there will be a spectrum of it, high and low, and I think most people will get it in there. In the second equation, we could just do this. I was looking for something a little bit better. You know, the Evel Knievel jump is a good way to do that. We could get the running speed, jump on the bike potentially. This is a nice clean way to do this. Land on the 9 meter long jump, figure out the angles and stuff, because you would want to snapshot that, which he does inside of here, and saying I could be a bit abusive. I could just run the trials, but now that I know that, let's say we didn't have some number. You're coming at me without a PT test number. Without that base of that equipment, yeah, I could get you here, but it's not going to do you a lot of good unless you have the fundamental science to grind out the math like that. Because grinding out the math like that would be valuing what that is. Here's the run speed experiment parameters, the photo of the first guy, or because in a series of logarithms of sets of powers to that test being done, you would find that the most common ratio or range for what this is hopefully this number between 1.8 meters tall and some average run speeds for 9 feet. I think I could get 9 feet, I bet, and get good run going, and under that limit of what the long jump would be, that's what you could do with that. But again, you need the game theory. What is the long jump to determine what that is? And we're inverting that into the game is to solve what Salty is or Sharp is doing. Salty or Sharps is potentially going to be doing in that event. And so that's going to be like the physics, and I want you to eventually get into that. I know in the stone mills and stuff like that, eventually we'll talk about rotational force.
We're talking about how to achieve
in a
a
saw
9 meter long
or
jump.
rotational, even though
Let's
it's
say
not
we have a
reciprocal
jumper
is
who
like
is
that,
1.8 to
still
1.9
rotating
meters tall.
angular to
First,
linear
the
to potential
difference in height of the center of
types
mass at
of
takeoff and
fields,
touchdown,
where
we're
at the
estimating
linear
at
level
60 centimeters. Then we're estimating
the ball and
takeoff
weight is
distance to be
here.
40
There's also a
centimeters
bit of
and the
inertia
landing
if I
distance to
hit
be
if
40
I hit
centimeters.
something. And
So
you
we need
could
the center
say
of
at
mass
that
to
point in time,
travel
if I
8.2
clip
meters
something,
during
how much
flight.
energy was
Couple
delivered
examples of
into
how that
that
could be
system.
accomplished.
That's hard to tell. The
One, we
ball
got
may not break.
9.1
It's not
meters per
a
second
really good
horizontal flight
indicator
speed.
of what that
Okay,
is.
to
But
get
if you did
8.2
know,
meters, we would need
wow, you just
0.90
blew out a
seconds in
2
the
by
air.
4 in there.
We do a little math, we find out
What's
that
the
would
rough
require
average
69
to
centimeter
have
vertical
that
jump.
effect on a hydraulic
Okay.
ram
Another
to
example, this would be a very high
punch
flight speed,
to
10 meters per
IH
second.
get
That's
the
going to require
replication of what had
0.82
happened
seconds
there.
in
And
air,
again, you might not be able
and
to
that would
recreate that
come from
experiment
a
because there's just
52.5
he
centimeter
hit it and the
vertical
wood
jump.
exploded.
So at first
But I need
glance,
that
these
rough
numbers
area
might seem kind of
of
doable,
what
right?
that
Because
was
these
by
vertical jumps are
hydraulic
not
feet,
super
and
high.
then I'll look at this and be
What
like,
makes the
does
9 meter long
that
jump so
in
unattainable
other
is the
fields
speed
generate
requirement.
that kind of thing?
Right.
Does that seem
So if we
rational?
have this much speed
And if
after
not,
takeoff,
are they on the
and we got this
bandwidth
much
of that
pop,
rational
we're probably
nature
gonna have
of
to
looking at
approach
them?
at
He's
about
friggin'
10.5
Norwegian.
meters per second. Okay? And to approach that fast,
So I like
and
what they're
be able to
doing,
jump this high,
but again,
you're probably going to have to be capable of sprinting close to 12 meters per second. Now, same thing over here.
12
This is
meters
not
a
as much of
second,
a vertical pop,
3
but
steps,
to have this much
3
speed in
steps,
the air, you're still going to have
that's
to be
doable.
approaching probably close to 11 meters per second. Okay? And to approach that
Miles
fast,
an
and
hour
get
may
this much
not be
pop,
accurate
you're
enough. You
probably
need
going to have to be capable of sprinting close to 12 meters per second.
milligrams.
So this brings me to
100
my point.
milligrams, 500
That
milligrams,
the reason that we're
1,000
mostly
milligram
long jumping
beaker.
under 8.5
They
meters
give you
is
where the
because we don't
landing
have
spot
enough
would
of our
be because I need
fastest
something in that
athletes long
class. Or
jumping.
what am I looking for?
Okay, I think we got lots of guys who probably run maybe like 10.3, 10.5, and 100. We need some 10.0, some sub 10 long jumpers. Okay? So if you're a long
In the
jumper,
stone mill.
look at your flying 20. All right? If you can get that down to maybe like 1.70 seconds, then you're going to be the type of jumper that could challenge the world record.
Here we
Now,
go.
one more point. a
we're changing
taller
out the
jumper,
test a little bit.
that's going to
And that's
increase
one of the things in
some
life.
of
This
these
is nice
distances
and
that we
clean with
estimated, right?
stuff. That's
And that's going
fantastic.
to decrease
As far
the
as physics
speed
and
the vertical
mathematics and
pop
organic
requirements to get
chemistry
that
or
9-meter long
chemistry
jump.
or
All right. So if we look at Usain Bolt, the guy was
just
almost
whatever
2
you're
meters
looking
tall,
at here.
and in his prime, he sprinted 12.3 meters per second. All right. Bolt could have been a 9-meter long jumper.
It could have been. So one of the things I tell you about, see, this is a different test now. Do you like that parameter? Do you like the way they do it? Could you set that up not just to this, but here, given the math subjects, we'll get more competitive logarithms, algebra or arithmetic, Coulombs, and Gauss, right? Electric ladder stuff. And we'll be playing that here. One of the tests is to change over what numbers they're inputting. So if these are the rates in which they're now timing their systems off of, that's a test. That's I've changed this field. It was originally one problem at a time and work it out, but I kind of idealized that, hey, you can do that the same way, and basically what you're doing is all the same work, right? We're showing the equation, we're rewriting the expression. We're going to do it out like that, but here commonly, instead of the ratio versions that generally do that field, or closely three-phase or two-phase, high and low, but three-phase motors, depending on which equation you wanted to do, I'm changing the test. And I might need to do that again. I might need to chisel that in for whatever reason, some kid or situation or whatever comes at you, to again change that test. I'm going to need some overhead. Tell me about your task. What's your landscape and design? Too much. What's your landscape and design on this one here for that, or hardscaping, or home moving, doing mathematics with people for costs, or making hillbilly spinners? You know what I mean? Is which route are you going? Because the math to the photoelectric effect, it'll always be there. It was always going to happen, superposition, 0-1 stuff in the world. But at the same time, P cannot be Q, right? They can be very close, but I need 2 points to make the line. We both agree that, at least looking at it that way, would be a reasonable subset of how, well, you could say, for sure, this one is the main house, the read technique in this house. I'm gonna move stuff around, isolate you, whether it be by training or you're a suspect or you want to be a cop. You want to do that. There's something going on, but you have to understand here, everybody shares that in the box because there's always some temperature differential. Was the door locked, not locked? Schrodinger's cat inside of here. Could be me in one position or me and some other ones here. And, again, you got to take that stuff into consideration. No, for sure. If you like it, that's great. It's a great business model. We could talk about, I have a STEM grow as far as seed to timelines to spectrums, and what's a good one here? Evaluations on a person work the same way. You just need the substrate, right? If the substrate was a business, it doesn't matter because, we could make stonemasons, and that would be, or farmers would be a better concept to what the result is, because, well, what is it? Well, they look the same. They're a different color and there's different lights, but it's space-time, damn it. Alright, so that's my note. Catch you on the next one.